Spherical coordinates. So yesterday we talked about cylindrical coordinates. So we moved rectangularly in the XY plane, and then no, that's not right. We moved circularly in the XY plane, and then we moved up or down Z. Okay. Spherical coordinates. What does that sound like we're going to do?
Did you actually?
Oh, you already looked it up?
The first page and I hated it, so I stopped.
Okay. Rho is the distance between P and the origin. Like row your boat. Rho. Density is the letter rho. Okay. Theta is the same angle we use for cylindrical coordinates. What's this? Phi. That's what Mr. Holman's class said too. They said this is a Disney Y.
Oh, it is.
We've been teaching this for 10 years, and this is the first year that, and separately, both classes have said anything, and I can't like unsee that now. So phi is the angle between the Z axis and the line segment, okay? So it's basically, we rotate in the XY plane, and then we rotate up or down. Does that make sense?
That's why I stopped.
So it's like you need two angles and then you move out row.
Oh, that thing.
So rho is kind of in place of R, then we have theta, then we have phi. That looks like, because it takes into account the third dimension, where R is just 2 dimension. No, I know, but R only took into account 2 dimensions because we went like in the XY plane with R. Are you understanding what I'm saying? Okay. Please do not feel like you have to draw this picture.
So, good.
Yeah, if we want to move backwards. Wait, see? Because it's going to be between like the segment and the Z axis. So it's either, it doesn't say positive Z axis, just the Z axis in general. Oh yeah, positive Z axis. Okay, positive Z axis, sorry. So if we think about like no matter how we rotate, we're always going to be less than 180 degrees away. Why are you laughing when I'm trying to explain something to you? Like, do you know how that makes me feel? Okay. Here are our conversions. Do I need to go back? For like 2 seconds. 1, 1.5,
Is that like?
This right here.
Yeah.
So this is rho. Phi.
Oh.
Okay, so let's talk about these first. To change from rectangular to spherical. Whatever. Rho is the square root. Rho is basically three-dimensional distance. Since theta is the same, the tangent of theta is still y over x. And then look at phi. So do you notice how we have rho with cosine theta for x and rho with sine theta for y? Do you see that? They just have the sine phi, and then z is rho cosine phi. Are you noticing that? Trying to help you figure out how to remember it. Ready? Okay, so we're gonna do the same thing where we're just gonna like convert back. We're gonna convert 1, 1, 1 from rectangular to spherical. All right. So rho is the square root of x squared plus y squared plus z squared. So what's rho? Radical 3, we'll just keep it as radical 3. Okay. Theta, we know that the tangent of theta equals y over x. Okay, so that's the same as it was for polar coordinates. Okay, so if we think about just the xy, that would be in the first quadrant. So we need a first quadrant angle, which would be pi/4. Okay, and then phi. Phi is the inverse cosine of z over rho. Did you notice that? How it's just z over rho? Okay. Okay. With your calculator in radians, what is the inverse cosine of 1 over radical 3? So exciting. All right, we're gonna go the other way. We're gonna convert spherical to rectangular.
I did these ones, I think, except for this one. Or this one.
All right, so here we have rho theta phi. X is rho times the sine of phi times the cosine of theta. What does that get us? Five times radical 2 over 2 times equals 5/2. Y is going to be 5 sine of phi sine of theta. So also 5/2. Z is going to be rho times the cosine of phi. Which would be positive or negative? Negative. So we have 5/2, 5/2, negative 5 radical 2 over 2. Okay. Now we are going to do 3 problems where we're going to take an equation and convert it. Okay. You giving? Tired? Okay. I'll try to keep you awake. I want to convert this from rectangular to spherical.
Yeah. For this one.
Yep. All right, so what do you notice? What's this the same as? Okay. And what is Z the same as? Okay. So we can say that rho equals 4 cosine phi. What do we have? Look at this right here. We have a sphere, don't we? Yeah. If we complete the square, we have a sphere. So that we can figure out that the center is at 0, 0, 2 with a radius of 2. That, okay.
Oh.
I guess that's my last example. Yeah. Yeah, guys, that was the last time we were taking notes. Ever. Okay, so this is what we need to do. Right now, we need to work on the rest of the 11-7 assignment. When you're done with that, here's your review. Two o'clock.
So if we finish our review and our
I don't think I can like.
why?